Welcome to the last lesson under this topic, periodic trend. Under this lesson, you should be able to describe periodicity in the periodic table, should be able to explain the causes of variations of elements property in the periodic table, and we should be able to discuss the trends in reactivity down a specific group. Let's get it started. Periodicity with respect to periodic table is the variation in the properties of elements in a regular pattern both down the groups and across the period. So there's a kind of variation experienced in a periodic table, or a kind of variation that exists in a periodic table. That is, there's a kind of gradual changes in the properties of elements, and these changes follow a kind of regular pattern either down the groups or across the period. Now, two factors are responsible for the variation of the properties of elements. The two factors are opposing each other. The first of the factor is the effect of increasing positive nuclear charge, while the second factor is the screening effect of inner shell electron. Now, effects of nuclear charge is that the nuclear charge overpower the screening effect. Don't forget that I said these factors are opposing each other. So the nuclear charge overpower the screening effect of inner shell electron across a period, while the screening effect overpower the effect of nuclear charge down the group. Right? So across the period, the nuclear charge have more power than the screening effect. It nullify the screening effect across the period, while the screening effect nullify or neutralize the effect of nuclear charge down the group. Now let's look at one of the variation, which is the atomic radius. Atomic radius increases down the group. Down every group, the atomic radius of an element increases, which means the first member of a particular group has a smaller atomic radius than the following one, down a particular group. But across the period, the atomic radius keep decreasing. The atomic radius keep decreasing. Now, as you move from left to right, atoms have more outer electron. These are the reason. Atoms have more outer electron. So atoms have more proton in the nucleus and a greater nuclear charge. So this cause a kind of greater attraction between nucleus and electron. So the electron are pulled closer and the atomic size decreases as you move from left to right across a period. But down the group, the atoms have more shell of electron. The inner electron shell shield the outer electron shell from the nuclear pool. Then the outer shell of electron are less impacted by the nuclear charge. So this gives rise to the increase in the size of atom down the group. Let's look at another variation, ionization energy. Ionization energy is the energy required to remove 1 mole of electron from 1 mole of gaseous atom to produce 1 mole of gaseous ions. Now, ionization energy increases across the period from left to right, and it decreases down the group from top to bottom. Another variation is electronegativity. Electronegativity is the power of an atom of an element to attract electrons to become negatively charged. Now, electronegativity decreases down the group from top to bottom and increases across the period from left to right. Another variation is electropositivity, just like an opposite to electronegativity. It's the power of an atom of an element to lose electron and become positively charged. Electropositivity increases down the group and decreases across the period. So from top to bottom, it increases, and from left to right, it decreases. Another variation we'll look at is electron affinity. Electron affinity is the energy change which accompanies the addition of 1 mole of electron to 1 mole of gaseous atom of an element to form negatively charged ion. Electron affinity decreases from left across each period while it increases down the group. So electron affinity increases from top to bottom and decreases from left to right. Another variation we'll look at is ionic radius. Ionic radius decreases for metal across the period and increases for non-metal. So there's a kind of special effect when it comes to ionic radius. Ionic radius, when you're talking about metal, from left to right, it decreases. But the moment you get to the non-metal, it increases from left to right. But generally, it increases down the group and decreases across the period. So a quick summary before we wrap up the topic. Periodic trend is defined as the variation in the properties of element in a regular pattern, both down the groups and across the period. Two opposing factors are responsible for this variation in the property of element, and these factors are effect of increasing positive nuclear charge and screening effect of inner shell. Thank you for listening. Check my other courses, subscribe and enjoy. Thank you.